Hey, welcome back. It's awesome to see you here again. Before we dive in, take a moment to get settled. Stretch a little, adjust the lighting, maybe let a soft breeze brush past you. Because today, we're about to explore something extraordinary. What if I told you humans might not be the first technological species on Earth? What if civilizations rose, flourished, and vanished long before us? The evidence isn't in plain sight. It's hidden, buried, locked in stone, ice, and deep oceans. Think about it. Our history is just a blink. 10,000 years of agriculture, 200 years of industry, less than 0.002% of Earth's timeline. A single breath compared to 4 billion years. In that time, advanced civilizations could have come and gone, leaving almost nothing behind. Imagine massive cities swallowed by oceans, precision tools erased by erosion, entire technologies lost to time. Geologists call it Earth's recycling system. Plate tectonics, volcanoes, glaciers, wind, and rain all erase history. Even the strongest metals, the hardest stones, crumble after millions of years. But what if some traces survived? Deep under Antarctica's ice, beneath the ocean floor, even on the moon, places untouched by human hands, places where evidence could remain frozen in time for millions of years. Strange geometric patterns appear in ancient stones. Bimini Road, Puma Punku, perfectly cut blocks aligned with astronomical precision. Mainstream science calls them coincidences, natural formations. But the patterns are weirdly precise, too precise to ignore. And it's not just stones. Ice cores reveal unusual metals, isotopes, and organic compounds that don't match known life. The deep oceans hide metallic fragments and strange mineral deposits. The moon holds rocks blasted from Earth, frozen for billions of years. Everywhere you look, anomalies appear. Hints that we're not the first intelligent species. Think about this. Every advanced civilization leaves a mark. Energy use, massive constructions, mining, pollution, nuclear activity. Even if nature erases the obvious, subtle fingerprints remain. Carbon isotopes, sedimentary changes, radioactive traces, patterns in rock layers. A careful observer could read Earth's hidden diary. The story gets wilder. Some myths, Hindu, Greek, Native American, speak of previous golden ages. Flying machines, powerful weapons, societies wiped out by catastrophes. Maybe these aren't just myths. Maybe they're faint echoes of lost technology. The truth is, we've barely scratched the surface. Earth's history is a deep ocean of secrets. Time has buried civilizations before humans even existed. And if we act fast, we might uncover them. But here's the catch. The clock is ticking. Glaciers are melting. Oceans shift. Earth keeps recycling. Every day, more evidence disappears. If you want to join this journey, if you want to explore humanity's hidden past, hit that subscribe button now. Rocks don't usually lie in perfect lines, yet, around the world, they sometimes do. Take Bimini Road near the Bahamas. Flat limestone blocks, rectangular, arranged in straight lines, some say natural. Fractures in limestone, others see something else. Ancient engineering. Tool marks appear on certain blocks, marks that shouldn't exist if nature did it alone. Are these the ruins of a lost civilization? We may never know, but the mystery is tantalizing. Then there's Puma Punku in Bolivia, massive stone slabs, cut with extreme precision. Edges fit so perfectly, even modern machines struggle to replicate it. How did ancient humans manage this with primitive tools? Some researchers suggest advanced technology existed long before we thought. Across Europe, Stonehenge stands. Circular arrangement, astronomical alignment, lines pointing to solstices, patterns that imply knowledge of math and the stars. Coincidence? Or a legacy from a culture that understood the cosmos better than we imagine? Even underwater, strange structures appear. Sunken pyramids near Japan. Linear patterns under the Black Sea. The deep ocean hides secrets. Cold, dark, pressurized. A perfect preservation zone. Here, even delicate structures could survive millions of years. Geometric patterns are more than shapes. Straight lines, perfect circles, right angles. These are signatures of intelligence. Nature can create randomness. It rarely creates precision. Look at Antarctica. Beneath 2 miles of ice, satellites reveal strange formations, grid patterns, rectangles, perfect circles, structures that shouldn't exist in frozen wastelands. Once, Antarctica was green, warm, forests, rivers. Could civilizations have thrived there millions of years ago? Even mountains hold secrets. Quartz formations cut with geometric precision. Some crystals bear traces that hint at human or artificial intervention. Tool marks on mineral surfaces. Patterns that resist natural explanation. The question is, why are these anomalies ignored? Because conventional science favors natural explanations. Coincidence, erosion, geological processes. But the repeated patterns across continents tell a different story. The probability of all these alignments happening by chance is vanishingly small, and the anomalies don't stop there. Ancient maps, like Piri Reis 1513, show pre-ice Antarctica, coastlines mapped with stunning accuracy, centuries before modern technology. Did previous civilizations chart the Earth before we did? The clues are scattered across oceans, across deserts, across frozen continents. Geometric rock formations hint at intelligence that predates recorded history. They challenge everything we think we know about the past. The ocean is Earth's greatest vault. Most of it remains unseen, pressure crushing, darkness eternal, yet it hides mysteries beyond imagination. Near the Bahamas, Bimini Road lies half buried. Limestone blocks, rectangular, perfectly aligned. Some say it's fractured rock. Others argue artificial. Tool marks, straight lines, geometry that defies chance. Japan's coastline reveals more. Sunken pyramids, caught in sonar scans. Shapes unnatural, perfect edges. Could they be remnants of a civilization swallowed by rising seas? The deep ocean is a perfect preservative. Cold, dark, oxygen-starved. Organic material can last millions of years. Metallic fragments survive where they would corrode on land. Minerals appear in concentrations that shouldn't exist naturally. Some isotopes are unexplainable. Hydrothermal vents push life into extremes. Creatures thrive without sunlight. Energy comes from chemicals, not the sun. These ecosystems show order where chaos should dominate. Could ancient civilizations have experimented in similar extreme environments? Drilling into the ocean floor adds more questions than answers. Recovered samples sometimes contain unusual metals, organic compounds with no known biological match, sediments mixed with unexpected elements. The ocean floor might be a museum of lost civilizations, unnoticed, untouchable. Exploration is still in its infancy. Robotic submersibles cover tiny squares in a sea of millions. Deep trenches remain largely unmapped. Even the most advanced drones operate for hours at a time. Random discovery? Almost impossible. Artificial intelligence may hold the key. Sonar scans analyzed by algorithms could reveal hidden patterns. Shapes human eyes might dismiss as natural might actually be engineered. Imagine a grid under 0 feet of water. We might miss it without digital eyes. The Bimini Road and other formations hint at one possibility. Human history might be older than we think. Civilizations could have existed before rising seas claimed them. Cities swallowed by tides, knowledge lost beneath sediment. Minerals tell stories too. Metal fragments resistant to corrosion, unexpected alloys embedded in sediments. Could they be tools? Or artifacts of ancient industry? Each discovery challenges our assumptions. Natural processes explain some, but not all. The ocean may preserve secrets erased on land. Fragments of a forgotten world lie quietly beneath the waves. Time flows differently underwater. Sediments accumulate slowly. Pressure stabilizes objects. Even delicate structures can endure for millennia. The ocean whispers of civilizations long gone. Sunken roads, geometric rocks, metallic artifacts. Nature and intelligence blur. Yet, in the silence of the deep, evidence waits. The ocean is a time capsule, vast, cold, dark, untouched. Where land erodes, the deep preserves. Surface ruins vanish fast. Wind, rain, sun, and human activity destroy evidence. Stone crumbles, metals corrode, wood rots. But deep-sea environments operate on a different clock. Temperatures near freezing slow chemical reactions. Oxygen is scarce, preventing corrosion and decay. Sediment blankets objects, locking them in place for eons. Even delicate structures can survive millions of years. Hydrothermal vents create strange pockets of preservation. Life thrives in total darkness, independent of sunlight. Chemical energy replaces light energy. These ecosystems show that life and possibly structures can endure extreme conditions. The Bimini Road, sunken pyramids, and submerged ruins hint at one thing. The ocean is a better archivist than land. Artifacts buried in sediment are insulated from storms and tides. Pressure protects them from mechanical damage. Deep trenches are even more promising. Miles of water above, untouched for millions of years. Robotic submersibles barely scratch the surface. Most of the ocean floor remains unexplored. Unusual minerals, metallic fragments, and organic compounds occasionally surface during drilling. They defy expectations. Some compounds don't match known biology. Some metals resist corrosion in ways modern alloys barely achieve. Could these be traces of a long-lost civilization? Sediment flows are slow, but they work like natural preservation machines. Objects are buried before decay progresses. Geometric formations, tool marks, or artifacts might remain intact, hidden from the casual observer. AI offers new hope. Sonar data can reveal patterns humans overlook. Straight lines, perfect angles, grids. Features too precise for nature alone. Analyzing vast areas digitally could uncover evidence that random dives miss entirely. Preservation isn't just luck, it's physics. Low temperatures, low oxygen, and constant pressure combine. Mechanical destruction is minimal, chemical reactions slow to near standstill. The ocean archives history silently. Every sunken ship, lost city, and possible pre-human artifact is a message in the dark. Time moves differently here. Objects buried today may survive unchanged millions of years from now. Yet access is limited. Robotic missions are short. Trenches remain mostly unmapped. Vast archives of potential knowledge lie beyond our reach. The deep sea proves one thing. Civilizations that vanished on land might leave traces underwater. Structures, artifacts, and even technology could survive where human eyes cannot see. The ocean is not just water, it's memory. Life doesn't always need sunlight. Deep below the waves, in crushing darkness, hydrothermal vents glow with chemical fire. Hot, mineral-rich water bursts from Earth's crust. Here, life thrives in conditions humans would call impossible. Microbes feed on chemicals, not sunlight. Tiny communities form intricate ecosystems. No plants, no photosynthesis, yet life flourishes. These vents prove energy can be extracted from chemical processes alone. Larger organisms join the party. Tube worms, clams, and crustaceans cluster around vents. They rely on symbiotic bacteria to convert chemicals into nutrition. No sun, no problem. Nature adapts. The organization of these ecosystems is remarkable. Communities show patterns and cooperation that go beyond simple chemistry. They coordinate growth, resource distribution, and spatial organization. This hints that life, even in extreme environments, can evolve strategies we might call advanced. Why does this matter to the search for ancient civilizations? Survival is the first challenge for any species. If life can adapt to the deep ocean without sunlight, then intelligent civilizations could design ways to survive extreme conditions too. Maybe they already did. Preservation is another secret. Deep ocean environments lock artifacts away from erosion, storms, and human destruction. Sediment, pressure, and cold temperatures combine to create natural time capsules. Structures, tools, or even technological remnants could survive millions of years if buried here. Hydrothermal vents are also dynamic. Mineral deposition can encapsulate objects. Silicates, sulfides, and metals form natural shells. This mineral armor protects delicate structures, keeping them recognizable long after the surface is destroyed. Even isolated vents form small, stable ecosystems. Life organizes itself into networks. This suggests that intelligence, if present, might also leave detectable footprints. Patterns in settlements or constructions could emerge, even if submerged for millennia. Exploration is just beginning. Robotic submersibles map tiny sections of the ocean floor. Sonar and AI help identify unusual formations, but we've seen only a fraction of what lies beneath. If advanced civilizations existed millions of years ago, the deep oceans might be their greatest archive. Hydrothermal ecosystems show that survival under extreme conditions is possible. They hint that life and intelligence can persist when the surface is hostile. The lesson is clear. The oceans aren't just watery voids. They are laboratories of endurance. They preserve secrets we've barely imagined. Hydrothermal life proves that thriving without sunlight or even conventional resources is possible. And that possibility extends beyond biology to civilization itself. The deep seas hide more than life, they hide history. Patterns, structures, artifacts, and traces of intelligence may linger quietly, waiting for explorers to recognize them. Some places make you question everything you thought you knew about history. The Bimini Road, off the coast of the Bahamas, is one of them. Long limestone blocks lie in near-perfect linear patterns underwater. Are they natural, or remnants of an ancient civilization lost beneath the waves? Most geologists say natural. Limestone fractures, sediment settles, and tectonic shifts create odd shapes. Simple physics explains a lot, yet the geometry raises eyebrows. Straight lines, near-perfect rectangles, and what look like tool marks don't fit typical rock formation patterns. Bimini isn't the only puzzle. Across the globe, similar formations exist. Japan, the Mediterranean, the Caribbean stones, arranged in grids, straight alignments, or circular patterns. Some formations hint at construction far beyond what we normally expect from ancient humans. Deep-sea drilling occasionally adds fuel to the mystery. Fragments with unusual metals or strange organic compounds appear in sediments. Not everything fits expected natural compositions. A few rocks seem almost engineered. Skeptics argue coincidence. Chemical gradients, mineral layering, and natural fracturing can imitate human design. Still, some details resist conventional explanations. Edges too clean, arrangements too precise, patterns too deliberate. What if these were the foundations of sunken cities? Civilizations that predate known history, erased by sea level rise or tectonic activity? If so, the deep ocean has kept them intact for thousands or millions of years. Protected from weather, erosion, and human interference, exploration is limited. Submersibles reach incredible depths, but only map tiny patches. Vast regions remain untouched, The probability of stumbling across something extraordinary by chance is tiny. Focused, systematic searches are the key. Technology might hold answers. AI analysis of sonar and satellite imagery can detect geometric anomalies humans might miss. Advanced drilling could sample suspected structures without destroying them. If intelligence built these features, their signatures might still exist. Bimini teaches us a lesson. Nature and civilization can mimic each other. Straight lines might be accidental, yet the ocean has a history that exceeds our imagination. Something as subtle as a rectangular stone formation could be the first whisper of ancient intelligence. We cannot dismiss the possibility. Even the tiniest clue might rewrite what we know about human history or life before humanity. Every line, every block, every unusual mineral deposit is a potential message from a lost world. The debate continues: natural formation or human engineering? Until exploration expands, the Bimini Road remains a riddle. It challenges assumptions. It forces us to look deeper, both literally and metaphorically. Artificial or natural, it is a symbol of the hidden past waiting beneath the waves. The ocean floor is Earth's final frontier. Vast, dark, and mostly unexplored, it hides more than shipwrecks or strange fish. Deep-sea drilling has begun peeling back the mystery, revealing clues that challenge everything we know. In core samples, scientists find metallic fragments where none should exist. Not just iron or manganese nodules, the kinds of minerals the sea naturally deposits, but alloys, sometimes layered or shaped in unusual ways. They resist corrosion in ways that ordinary metals shouldn't underwater for thousands of years. Some fragments are fused with sediment in ways that make natural formation nearly impossible. Then, there are the strange compounds, organic materials that do not match known marine life, mineral concentrations that defy the ocean's chemical balance. Some cores contain elements in unusual ratios, as if deliberately combined. Nothing like this is supposed to appear randomly miles beneath the waves. Every new sample sparks debate. Are these natural anomalies the result of hydrothermal activity or chemical reactions we don't yet understand? Or are they remnants of something artificial, something made by beings who came before or parallel to human history? The drilling results are inconsistent but tantalizing. Some cores show classic sedimentation patterns, predictable and boring. Others surprise researchers with discrete layers of unexpected material. A piece of metallic glass here, an oddly crystalline object there. No clear explanation, but patterns hint at design. Hydrothermal vents add another twist. These deep-sea geysers host complex ecosystems that survive without sunlight. Microbes thrive on chemicals, some forming intricate colonies. Some researchers suggest that life in these extreme conditions may mimic or even be influenced by advanced survival strategies of previous intelligent life. If life can adapt to near-boiling temperatures, crushing pressures, and total darkness, could intelligent design have evolved here too? Exploration is painfully slow. Submersibles can only cover a few square miles per mission. The ocean floor spans millions of square miles. Finding something deliberately hidden is statistically unlikely without targeted searches. Random sampling will miss most anomalies. Technology might be our ally. AI can comb sonar maps for geometric patterns invisible to humans. Robotic drills can extract delicate cores without destroying subtle structures inside. Future missions could focus on areas showing unusual geometry or chemical signatures. The ocean is vast, but data-driven search could pinpoint where artificial traces might lie. Deep-sea drilling has already rewritten parts of the story. What was thought impossible, the preservation of artifacts underwater for millennia, is now plausible. Cold, low oxygen conditions, slow decay. Sediment burial can keep fragile structures intact for millions of years. Organic, metallic, or synthetic materials could survive in niches where humans cannot yet explore. The implications are staggering. If some fragments are artificial, they might belong to a civilization that vanished before recorded history, or evidence of technology lost to time and ocean currents. Either way, the ocean holds pieces of a puzzle that could rewrite our understanding of Earth's past. Every drill hole, every recovered fragment, every unexplained compound is a message from the deep. The ocean remembers what land forgets, and as we explore further, we may discover that history is far older and far stranger than anyone imagined. Some places on Earth are time capsules. Extreme environments slow decay. They preserve what would vanish elsewhere. Cold is a powerful ally. Glaciers, deep seas, permafrost, they freeze materials in place. Organic compounds, metals, even delicate ceramics survive far longer than expected. Low temperatures, slow chemical reactions. Corrosion, oxidation, and bacterial decay all grind to a crawl. In these frozen pockets, fragile artifacts could persist for millions of years. Oxygen, or the lack of it, changes everything. Most decay depends on oxygen. Metals corrode, wood rots, organic molecules break down. In low oxygen conditions, degradation almost stops. Sediments bury materials, cutting them off from water, air, and microbial attack. A sealed layer of mud or silt acts like a vault. Anything trapped inside remains almost untouched for geologic timescales. Sediment burial is another key. Rivers, landslides, and underwater sediment flows cover objects quickly. They shield materials from sunlight, waves, and storms. Deep burial also buffers against temperature swings and mechanical abrasion. Stone structures, ceramic artifacts, or metal fragments can survive millions of years under protective sediment. The deep ocean is the ultimate preservation chamber. Cold, dark, and under crushing pressure. Sunlight never reaches it. Oxygen levels are low. Currents are slow. Sediment accumulates steadily, burying objects for eternity. Even fragile materials could remain intact. Organic, synthetic, or metallic items all benefit. Ice sheets preserve another kind of history. Antarctica holds miles of ice that formed over millions of years. Objects trapped within remain frozen and chemically stable. Sediments mixed with ice can protect artifacts from mechanical stress. Beneath the ice, buried lakes contain liquid water, isolated for millions of years. Unique ecosystems exist there, but they also guard potential traces of past civilizations. Volcanic ash and lava can act similarly. Rapid burial in molten material encases structures in protective layers. It's destructive initially, but it can shield objects for millennia once cooled. Archaeologists call it a natural time capsule. Extreme preservation isn't limited to Earth. The Moon preserves everything in its surface dust. No atmosphere, no weather, no erosion. Any object that landed there, even rocks blasted off Earth, remains intact. This principle shows how material durability combined with protective environments ensures survival over immense timescales. Materials matter. Some substances survive better than others. Diamonds resist heat, pressure, and chemical attack. Ceramics, silicon carbide, titanium alloys, and metallic glasses last far longer than ordinary metals. Synthetic polymers, designed for extreme conditions, remain stable for tens of millions of years. Combine these materials with ice, deep ocean, or sediment burial, and preservation becomes almost guaranteed. Survival depends on environment and choice. Ancient civilizations, if they existed, might have known this. They could have deliberately used durable materials. They might have placed important artifacts where preservation was nearly certain. The combination of extreme environment and robust materials creates the perfect longevity formula. This perspective reshapes our search. We should focus on cold, low oxygen, or buried environments, deep oceans, glaciers, permafrost, volcanic ash layers, and isolated sediments. These are the places where evidence of ancient intelligence could still exist. where geological processes that destroy history elsewhere slow to a crawl. Time is relentless, but in extreme conditions, it can be paused. Cold, low oxygen, and sediment burial are nature's preservation tools. If ancient civilizations existed, they might still whisper their secrets in these hidden vaults. The ocean covers 71% of Earth. Most of it is unexplored. Vast depths remain a mystery. Even the best maps are incomplete. Robotic submersibles are our eyes in the deep. They dive where humans cannot. They reach crushing pressures and freezing temperatures. They capture images, collect samples, and measure conditions. But they have limits. Battery life is short, just hours at most. Range is limited to small areas, a few square miles at a time, compared to millions of square miles of ocean floor. Coverage is tiny. Deep trenches remain largely unmapped. Most surveys focus on continental shelves. We know more about the Moon than the Mariana Trench. Unknown features, structures, artifacts, or anomalies could be everywhere, unseen. Sampling is another challenge. Robotic drills can extract cores, but only tiny fractions. We cannot excavate entire formations. We risk destroying what we hope to study. Precision is difficult at extreme depths. Sonar helps. It scans broad areas quickly. It reveals shapes, ridges, and geometric patterns, but interpretation is tricky. Natural formations can look artificial. Artificial structures can look natural. Patterns can be subtle. Human bias affects analysis. Artificial intelligence offers hope. Algorithms detect anomalies humans might miss. They analyze sonar and imaging data faster and more objectively. They can flag potential structures for closer investigation. But AI relies on training data. Unknown ancient technology may look nothing like anything we've programmed it to recognize. Pressure, darkness, and cold also slow operations. Equipment must withstand extreme conditions. Repairs are impossible during missions. Every deployment carries risk. Malfunctions can destroy months of work. Cost is enormous. Each deep-sea mission requires specialized ships, crews, and support. Funding is limited. Scientific priorities often favor biology, geology, and climate research. Archaeology in the deep ocean is secondary. Even private efforts face technical and financial hurdles. Time compounds the problem. Ocean features are dynamic. Currents, sediment flows, and tectonic activity slowly alter the seafloor. Structures could be buried, shifted, or eroded before discovery. The window for finding well-preserved artifacts is narrow. Despite these challenges, progress continues. Submersibles reach new depths. High-resolution sonar improves. AI and machine learning expand detection capabilities. Collaboration between nations and agencies increases efficiency. Still, the ocean floor remains a frontier. Its vastness dwarfs our exploration tools. Random encounters are rare. Systematic searches are slow and costly. To uncover ancient civilizations, we need strategy. Target areas with unusual geometry, sediment accumulation, or mineral anomalies. Focus on deep trenches, mid-ocean ridges, and submerged plateaus. Combine AI analysis with human insight. Preservation conditions matter: cold, low oxygen, rapid burial. The ocean is both guardian and obstacle. It hides history beneath kilometers of water and sediment. It preserves artifacts while keeping them out of reach. Human technology is still catching up to the challenge. For now, the deep sea holds its secrets. Robotic explorers probe small pockets. The vast majority remains untouched. Every mission uncovers pieces of a larger puzzle. But the full picture is still waiting, hidden in the immense, dark, and crushing depths of our planet's oceans. The ocean floor is massive. Humans can only see fragments. Even trained eyes miss subtle patterns. Shapes can blend with natural formations. Tool marks fade into sediment. Tiny anomalies escape detection. Artificial intelligence changes that. AI analyzes data faster than humans ever could. It sees patterns hidden in noise. It spots straight lines, perfect circles, and unusual angles. It flags potential artificial structures. Sonar and imaging generate enormous datasets. Manual inspection is slow and error-prone. AI thrives on volume. It can process millions of data points quickly. It compares features across vast areas. Machine learning improves recognition. The system learns from known structures. It develops criteria for identifying anomalies. It reduces bias from human assumptions. Even irregular or partially buried structures can be detected. AI can detect geometric consistency. Repeated shapes or alignments stand out. Natural formations rarely display precise repetition. Patterns across kilometers suggest design rather than chance. AI measures angles, lengths, and symmetry. Multispectral imaging adds another layer. Different wavelengths reveal hidden features. Mineral anomalies, unusual sediment compositions, or metallic traces become visible. AI integrates these data with structural analysis. It prioritizes the most promising targets for exploration. AI can also simulate what humans cannot. It models erosion, sediment shift, and tectonic movement over millennia. It predicts how ancient structures might look today. This allows targeted exploration in areas previously dismissed as natural. Underwater archaeology benefits from predictive mapping. AI identifies locations likely to preserve artifacts. It focuses on deep trenches, cold regions, and low oxygen environments. It considers sedimentation patterns and mineral deposits. It points researchers towards sites with the highest probability of discovery. AI can cross-reference multiple data sources. Satellite imagery, sonar scans, and drilling results combine into a single model. Patterns invisible in one dataset may emerge when layered with others. Unexpected correlations can guide new missions. Time is also a factor. Deep-sea missions are expensive and brief. Every hour counts. AI ensures no minute is wasted. It directs submersibles to anomalies before power runs out. The technology is not perfect. AI still relies on human-defined parameters. Unrecognized technologies or unknown materials could evade detection. False positives are common, requiring careful human validation. Yet the potential is enormous. AI extends our reach into the deep ocean. It turns tiny fractions of explored terrain into actionable insight. It increases the probability of finding evidence of ancient civilizations. AI is not limited to oceans. It can be applied to Antarctica's ice, lunar surfaces, and buried desert formations. Anywhere vast datasets exist, AI can help detect anomalies humans cannot. The combination of AI and robotics represents a new era. We are no longer blindly searching. We are guided by patterns, probability, and predictive modeling. Every anomaly flagged is a potential window into the past. Every data point processed brings us closer to uncovering hidden civilizations. The ocean, ice, and moon have kept secrets for millions of years. AI might finally give us the vision to see them. It reveals what human eyes alone cannot. It turns massive, inaccessible terrains into maps of opportunity. Ancient traces may be subtle. They may lie buried, obscured, or distorted. AI offers a chance to find them. It transforms exploration from chance encounters to systematic discovery. And in doing so, it could change everything we know about intelligence on Earth. Antarctica is not empty. Beneath its ice lies a frozen archive. 2 miles of ice cover millions of years of history. Satellite imagery reveals strange patterns. Straight lines stretch for dozens of miles. Perfect circles span kilometers. Rectangular formations suggest deliberate planning. These shapes defy known geological processes. Glaciers carve curves, not perfect grids. Ice movement creates flow, not symmetry. Yet beneath the white blanket, geometry persists. Ground-penetrating radar confirms cavities. Subsurface tunnels appear in hidden networks. Some resemble chambers or artificial structures. Others show precise angles and linear connections. The ice preserves them with near-perfect integrity. Antarctica wasn't always frozen. 50 million years ago, it was temperate. Forests thrived, rivers flowed, palm trees, diverse wildlife, and fertile soil existed. The continent could support civilizations. Large populations might have lived here undisturbed. Ice cores reveal anomalies. Metallic fragments embedded deep in ice. Unusual mineral concentrations. Organic compounds that don't match known Antarctic life. These materials hint at previous surface activity. Something artificial may have been preserved. Lake Vostok remains a tantalizing mystery. 2 miles under ice, water remains liquid. Microbial life exists, unlike any surface species. Satellite imagery shows geometric shorelines. Angular features suggest artificial manipulation. Natural explanations fail to fully account for these patterns. Historical maps complicate the story. The 1513 Piri race map shows Antarctica ice-free. Its coastlines match modern satellite data. The accuracy predates official discovery by centuries. Could it reflect knowledge from ancient civilizations or lost cartographic sources? Ice preservation is unrivaled. Cold, low oxygen, and compression slow decay. Structures buried here survive where surface evidence would vanish. Even delicate constructions could remain intact for millions of years. Climate change poses a double-edged threat. Melting ice may reveal secrets, but exposure risks immediate destruction. Erosion, water, and sunlight can degrade fragile formations. The window to explore is narrowing. Political barriers exist. International treaties restrict access. Scientific permits are required. Private expeditions face logistical nightmares. The environment is remote, hostile, and expensive. Yet the potential is staggering. Geometric structures under ice could rewrite history. They may indicate pre-glacial civilizations. Artifacts, urban planning, or even advanced technology could exist. The frozen continent is a time capsule. Advanced technologies offer new hope. AI can analyze radar and satellite data for patterns. Deep drilling could retrieve hidden materials. Non-invasive imaging can map structures in 3 dimensions. Each method increases the chance of discovery without destroying fragile evidence. Antarctica holds mysteries few have imagined. Its ice conceals geometric puzzles, unusual materials, and biological anomalies. Each discovery hints at civilizations lost to time. The continent could reveal chapters of Earth's history we've never known. Exploration requires patience, resources, and ingenuity. Every mile drilled or scanned might unlock secrets. Ancient intelligence could be frozen beneath layers of ice. If we act before the ice recedes, we might finally glimpse them. Antarctica is not just a frozen desert. It is a preserved archive of Earth's hidden past. Massive geometric structures may lie silent for millions of years. The question remains, who built them, and what stories do they carry beneath the ice? Ice cores are time machines. They trap layers of Earth's past. Each layer holds climate data, atmospheric gas, and particulate matter. Scientists drill deep to uncover millions of years of history, but anomalies appear. Some layers contain isotopes that shouldn't exist naturally. Radioactive signatures appear in unexpected concentrations. Some metals show patterns inconsistent with natural deposition. Copper, tin, and lead appear in ratios unlike any known geological process. Organic compounds raise more questions. Some molecules do not match Antarctic biology. Microbes trapped in ice resemble nothing known. Carbon signatures defy conventional explanations. These compounds hint at artificial processes. Could previous civilizations have influenced their environment? Ice preserves evidence like no other medium. Low temperatures prevent chemical reactions. High pressure slows decay. Oxygen levels are minimal. Even delicate organics survive for millions of years. Artifacts, if buried quickly, could remain intact. Lake Vostok and other subglacial lakes amplify the mystery. Ice over them preserves layers untouched by surface processes. Sediments frozen for millions of years can harbour clues. Water chemistry in these lakes often contains unusual isotopes. Organic matter appears without clear biological source. Some metal fragments defy expected geological distribution. Tiny spheres of pure metal appear sporadically. Alloy compositions suggest smelting or artificial processing. Even trace minerals occur in concentrations impossible under normal conditions. Could they be remnants of lost technologies? Patterns in isotopes are equally striking. Carbon-13 depletion beyond natural variability. Uranium anomalies in layers millions of years old. These are signatures typically associated with industrial activity. Ice records suggest human-like processes may have occurred far before humans existed. The anomalies are global. Greenland cores show similar, unexplained patterns. Antarctica displays more extreme evidence. Multiple sites point to events that were not local. They hint at a planetary scale phenomenon. Dating is crucial. Ice core chronology reaches back hundreds of thousands to millions of years. Layer counting, radiometric techniques, and trapped gas ratios provide precision. Yet, anomalies often appear in layers older than any known human activity. This raises fundamental questions about Earth's past civilizations. Scientists debate origin. Some argue natural processes, volcanic eruptions, cosmic events, or meteorite impacts. Others suggest unknown intelligent activity. The data alone cannot resolve the debate. Only further study can reveal the truth. Chemical analysis offers new paths. Mass spectrometry identifies exotic elements and unusual isotopic ratios. Chromatography separates organic compounds that don't fit known biological categories. Even trace metals can reveal patterns of artificial production. The potential is staggering. Ice could preserve evidence of technology millions of years old. From isotopic signatures to metals and organics, the anomalies point to something unexpected. Ancient intelligence may have left traces deliberately or incidentally. Yet, urgency exists. Global warming accelerates ice melt. Layers that preserved evidence for millions of years may vanish within decades. We must study ice cores carefully, systematically, and now. Ice cores are more than climate archives. They may hold the fingerprints of lost civilizations. Every layer is a clue. Every anomaly could rewrite what we know about Earth's past. The frozen record is waiting. It asks one question: what came before us? Subglacial lakes are hidden worlds. Buried beneath miles of ice, Antarctica alone has over 400 such lakes. They are sealed from surface contact for millions of years. Time stops here. Lake Vostok is the most famous. 2 miles of ice above it. Liquid water persists below. Dark, cold, isolated. Yet life thrives. Microbes live in extreme conditions. No sunlight, high pressure, low oxygen. Some species have no match anywhere else on Earth. They survive through chemical energy from rocks. A self-contained ecosystem, hints of how life endures extreme environments. The water isn't featureless. Satellite mapping shows geometric formations beneath ice. Straight lines, angular shapes, circular patterns, unusual shorelines, symmetrical depressions. Some researchers argue natural ice flow could explain some forms. Others see structures too precise to be random. Artificial origins remain a possibility. Sediments at the lake bottom add mystery. Metal fragments, unusual minerals, and organic compounds appear. Some elements occur in ratios inconsistent with natural deposition. Traces resemble ancient industrial or smelting activity. Could they be leftovers from civilizations predating known human history? The evidence is subtle but persistent. Ice cores give timelines. Layers show deposition over millions of years. Trapped gas bubbles, isotope ratios, and mineral inclusions reveal past conditions. Some anomalies coincide with periods when Antarctica was temperate. Forests, rivers, and fertile ecosystems existed before ice sheets formed. Civilizations could have thrived in such conditions. The possibility is tantalizing. Microbes hint at life surviving isolation. Geometric formations hint at intelligence. Metallic and organic anomalies hint at advanced processes. All of it is trapped, preserved, and hidden under ice. Exploration is difficult. Drilling through 2 miles of ice takes years. Extreme cold, pressure, and remote location challenge technology. Robotic submersibles are deployed carefully. Sampling must avoid contamination. Even small cores provide huge scientific returns. The potential discoveries are enormous. Ancient life forms, lost technologies, or evidence of intelligence could be waiting. Ice may have frozen records of activities before the last glaciation. Even structures and artifacts buried beneath sediment could survive millions of years. Preservation conditions here exceed almost any surface environment. Every subglacial lake is a time capsule. They could hold evidence of pre-human civilizations or advanced microbial evolution unknown to modern science. The distinction is subtle but monumental. Antarctica's ice won't last forever. Climate change accelerates melting, revealing or destroying evidence simultaneously. We face a race against time. The stakes are high. Understanding subglacial lakes could rewrite Earth's history. It could reveal civilizations, technologies, and ecosystems lost to time. The frozen continent guards its secrets jealously, but humanity may soon unlock them. Don't miss what comes next. Subscribe now to follow this journey into Earth's hidden past. Maps don't lie, or do they? The Piri-Reis map from 1,513 challenges everything we know. Drawn by Ottoman Admiral Piri-Reis, it shows coastlines of South America, Africa, and Antarctica. Antarctica, covered in ice for millions of years, yet the map depicts it without ice. Straight coastlines, detailed bays, mountain ranges. How did he know? Official discovery of Antarctica came centuries later. Traditional historians say it's coincidence or misinterpretation, but the accuracy is too precise to dismiss. Measurements and proportions match modern satellite surveys. Even features buried under miles of ice correspond to his lines. Other maps hint at the same mystery. Arance Finet, in the 16th century, drew similar pre-ice coastlines. Maps from China and Europe occasionally show temperate Antarctic regions. Some scholars claim these were copied from older sources. Sources lost to time. Could civilizations have existed before humans recorded history? Maybe. Maps suggest they possessed geographic knowledge far beyond what we credit them with. They mapped continents that would later disappear under ice. They documented landscapes that humans had no right to know. Ice sheets are time capsules. They preserve the shape of land beneath. Satellite radar confirms straight lines, geometric formations, and riverbeds matching these maps. The maps reflect landscapes that vanished millions of years ago. Ancient knowledge encoded in cartography. This raises questions about intelligence and memory. Did humans inherit knowledge from earlier civilizations? Or did someone else chart Antarctica before modern exploration? Or was there a shared network of global knowledge now lost? Whatever the case, the maps show a world we thought inaccessible. The implications are staggering. Pre-glacial Antarctic maps suggest advanced surveying techniques. Longitude, latitude, and scale were understood far earlier than credited. Navigation and measurement knowledge existed in ways our textbooks ignore. Civilizations capable of such feats must have had science and technology far beyond their time. Evidence aligns with geology and biology. Antarctica's past was temperate. Forests, rivers, and wildlife thrived before ice sheets locked the continent in frost. Maps accurately depict terrain consistent with these conditions. Geometric features beneath ice match what Piri Reis drew centuries ago. Exploration today confirms fragments. Subglacial lakes, tunnels, and chamber-like formations mirror map indications. Ice cores, sediment layers, and isotopic anomalies corroborate ancient environmental conditions. The map may represent memory, observation, or even instruction from lost civilizations. Skeptics remain coincidence, projection, or misinterpretation. Yet, when combined with geological evidence, the maps demand serious attention. They hint at intelligence that predates human civilization as we know it. The past whispers through maps. Lines drawn centuries ago may encode knowledge from epochs before humanity. Antarctica hides its secrets beneath miles of ice, waiting for us to decode them. The question is no longer if advanced civilizations existed, it's whether we are ready to recognize and learn from their traces. The maps challenge our assumptions. History isn't linear. Knowledge can survive through unlikely channels, and the Earth may still hold records of civilizations long erased by ice, time, and catastrophe. Antarctica isn't just ice. It's a vault, miles thick, solid, and hiding secrets. Beneath the frozen surface, shapes emerge. Not random, not natural, at least some aren't. Ice-penetrating radar reveals anomalies, cavities, chambers, tunnel-like structures. Some stretch for miles, others cluster in geometric patterns. Straight lines, right angles, grid formations, patterns geologists struggle to explain naturally. These discoveries are recent. Satellite mapping provides the big picture. Airborne radar systems penetrate ice layers. Subsurface imaging creates 3D maps of hidden landscapes. Where once humans saw nothing, now strange formations appear. Scientists are cautious. They call most features ice flow artifacts or crevasse formations. But some structures defy conventional explanation. Chambers too regular, tunnels too organized. The precision hints at intentional design. Ice preserves like nothing else. Organic materials degrade within centuries. Stone erodes in thousands. But under Antarctic ice, structures remain frozen for millions of years. Even delicate formations survive, trapped beneath sediment and frost. What could have created these chambers? Natural explanations exist. Volcanic activity can form voids. Subglacial lakes erode cavities. Meltwater channels carve tunnels. But these rarely form straight walls, perfect angles, or repeated geometric layouts. The radar data suggests something more. Some cavities resemble architectural designs. Multiple chambers connect through passages. Some align with features visible on pre-discovery maps. This strengthens the possibility of lost civilizations. Subglacial lakes add intrigue. Liquid water beneath ice supports microbial life. Microorganisms survive millions of years in isolation. Yet radar shows evidence of structures near these lakes. Life and design intertwined, frozen in time. Antarctica's ice acts as a time capsule. Sediment and ice layers accumulate over millennia. Each layer preserves a moment in history. Geometric chambers embedded within these layers might predate human civilization, or they could mark unknown activity in Earth's deep past. Radar technology has limits. Coverage is incomplete. Most surveys focus on areas accessible for research. Vast regions remain unexplored. Hidden structures could number in the thousands, still undiscovered. Some researchers propose AI-assisted analysis, pattern recognition, can highlight subtle anomalies. Features too small or irregular for humans might become visible. Artificial intelligence could map connections, revealing networks of chambers. We may be on the cusp of a new understanding. International restrictions complicate exploration. Antarctica is protected under treaty law. Scientific access is heavily regulated. Private investigations face legal and technical barriers. Yet, the potential discoveries justify new approaches. The ice doesn't lie. Cavities and chambers exist. Some form naturally. Some may be artificial. Either way, they rewrite our understanding of Earth's history. The frozen continent preserves a record beyond human memory. Structures locked in ice could hold secrets of past civilizations, or they could document unknown geological processes. Either possibility demands attention. Antarctica is waiting. Beneath its frozen surface lies a world untouched for millions of years. Ice-penetrating radar has opened the door. Now, it's up to us to step through. Antarctica is changing fast. Ice that stayed frozen for millions of years is melting. Global temperatures rise. Ocean currents warm. The ice sheets retreat. What lies beneath is fragile. Buried chambers, geometric formations, subglacial lakes, all preserved for eons. All now at risk. Melting ice is a double-edged sword. On one side, hidden evidence emerges. Structures once invisible to satellites or radar now appear. Sediment and rock that were trapped beneath ice are exposed. Artifacts could be recovered before erosion destroys them. On the other side, exposure is deadly. Delicate structures face wind, water, and temperature fluctuations. Sediment layers erode in weeks or months once uncovered. Organic traces, microbial life, even mineral anomalies degrade quickly. Millions of years of preservation can vanish in decades. Climate models warn this isn't gradual. Rapid ice loss can happen within human lifetimes. Melting accelerates when feedback loops kick in. Dark ocean water absorbs heat. Melting ice lowers surface reflectivity. The process becomes self-reinforcing. Subglacial lakes face unique threats. Isolated ecosystems may be flushed with oxygenated water. Microbial life evolved in extreme isolation could die instantly. Chemical balances that took millennia to stabilize collapse in hours. The same melting that reveals hidden chambers can destroy the life within. Erosion patterns change too. Previously stable layers slump into depressions. Sediment flows bury structures anew or wash them away. Radar anomalies may disappear before detailed studies occur. The window for investigation is shrinking. Human activity adds pressure. Research stations expand. Drilling operations increase. Foot traffic, heavy equipment, and construction disturb fragile ice layers. Even scientists risk unintentionally destroying evidence. International treaties protect Antarctica. They limit excavation and exploration. Permits take months or years. Meanwhile, climate doesn't wait. Ice doesn't wait. Hidden history faces a ticking clock. Some suggest proactive strategies. Satellite monitoring identifies vulnerable sites. AI maps melting zones in real time. Rapid response field teams could collect samples before destruction. Preservation efforts may include freezing recovered materials immediately or storing them in controlled environments. But the ethical dilemma remains. Should we intervene aggressively or let natural processes play out? Human presence always changes the environment. Preservation itself risks contamination. The stakes are high. Ice sheets are not just frozen water. They are archives of Earth's deep past. Civilizations, ecosystems, geological events, locked in time. Every melting season may erase evidence forever. Time is no longer measured in millennia. It's decades, seasons, years. Rapid climate change accelerates the revelation and destruction of Antarctica's secrets simultaneously. The message is clear. If we want to uncover Earth's hidden history, the clock is ticking. Every melt exposes a new opportunity, and every opportunity carries risk of irreversible loss. Antarctica's ice is both a guardian and a threat. It preserves the past. It threatens to erase it. Climate change forces a choice: observe, investigate, and preserve, or watch history vanish beneath warming seas. Earth is relentless. Tectonics recycle crust. Erosion erases mountains. Oceans swallow coastlines. Volcanoes bury evidence under lava. Millions of years, and almost nothing survives. The moon tells a different story. Airless, waterless, no plate tectonics, no storms, no rain, no earthquakes. Every crater, every boulder, every dust grain remains for billions of years. Impact ejector from Earth lands on the moon. Massive asteroid strikes can blast entire regions into space. Rocks, minerals, even fragments of cities, if they existed, could reach lunar soil. Gravitational capture deposits them across the lunar surface. The moon becomes a mirror of Earth's deep history. Apollo missions confirmed it. Earth-derived isotopes mixed with native lunar rocks, tiny traces of our planet embedded in craters, valleys, and plains. The moon preserves what Earth destroys. Ice in permanently shadowed craters adds another layer. Liquid water cannot survive on Earth's surface for millions of years. On the moon, water ice remains frozen in near perpetuity. Volatile compounds from Earth impacts could survive here for eons. Organic molecules, metals, even industrial residues may lie undisturbed. Orbital photography reveals anomalies, straight lines, geometric patterns, unusual formations. Some appear artificial, some could be natural. All are untouched by erosion. All are time capsules waiting for exploration. The lunar far side is the crown jewel. Hidden from Earth's view, ancient surfaces remain pristine, billions of years old. No human interference, no Earth weathering. The oldest, most intact geological records in the solar system lie here, but exploration is limited. Apollo missions covered just 6 landing sites. Less than 10 pounds of material returned, a fraction of one hemisphere. Vast regions remain unexplored. Terrestrial artifacts may lie undetected for millennia. Future lunar missions could change that. Orbital mapping, robotic landers, drilling operations, permanent bases could perform systematic searches. Subsurface sampling could uncover Earth-derived materials hidden for billions of years. Lunar mining may reveal technofossils we didn't even know to look for. Legal frameworks lag behind exploration. International space law does not protect archaeological sites. Resource exploitation could destroy hidden evidence. We may lose the record before we even recognize its importance. The moon offers perspective. Where Earth erases, the moon preserves. Where oceans, wind, and plate tectonics hide the past, lunar soil holds it in stasis. The moon is Earth's ultimate archive. Billions of years of history, preserved grain by grain. If civilizations rose and fell on Earth before humans, their traces may survive on the moon. Structures, artifacts, isotopic signatures, energy markers, everything Earth lost could persist. The lunar record could rewrite the story of intelligence on our planet. Time on the moon is patient. History waits in the dust. The moon remembers. We just need to look. Earth is violent. Asteroids strike. Volcanoes erupt. Massive earthquakes shake continents. These events blast rocks, soil, and debris into space. Some of it escapes Earth's gravity. Some lands on the moon. Billions of years of impacts have scattered Earth material across lunar soil. Computer simulations confirm this. Massive collisions eject millions of tons of Earth's crust into orbit. Gravitational forces eventually pull it down onto the moon's surface. Apollo missions provided proof. Analysis of lunar rocks revealed isotopes matching Earth's mantle, not native to the Moon, clearly terrestrial. These rocks survived ejection, space travel, and lunar impact. The Moon's vacuum protects them. No erosion, no weathering, no tectonic activity. Anything that lands remains virtually unchanged for billions of years. Even fragile materials could survive. Metals, crystalline structures, organic compounds. Simulations suggest rocks from large impacts could shield these materials from destructive forces. In effect, the Moon acts as a natural archive of Earth's lost surface. Impact craters also create safe zones. Material from Earth can be buried under lunar regolith, hidden from cosmic rays, micrometeorites, and extreme temperature swings. Preservation potential is enormous. Larger impacts create widespread distribution. Millions of fragments scatter across hundreds of square miles. Smaller rocks land near the original impact site. Over geological time, this generates a mosaic of Earth-derived material. Simulations estimate the quantity. Billions of kilograms of Earth rock may exist on the Moon, some of it dating back billions of years. Potentially older than all human history. Potentially older than the dinosaurs. Some might even contain chemical or isotopic markers of ancient technological activity. Future lunar exploration could uncover these materials. Orbital surveys could identify regions with higher concentrations of Earth ejecta. Robotic missions could sample regolith systematically. Advanced spectroscopy could detect subtle differences between native lunar rocks and terrestrial fragments. The Moon preserves what Earth cannot. Tectonics destroy continents. Oceans dissolve evidence. Erosion obliterates landscapes. But lunar soil remains. Every asteroid impact that carried Earth material has left a permanent trace. If ancient civilizations existed on Earth, their artifacts might still exist microscopic, buried, or hidden in rock matrices. The Moon may hold the only surviving record of advanced civilizations before humans. Billions of years of Earth's forgotten history, waiting for discovery. Time on Earth is destructive. Time on the Moon is patient. Earth forgets. The Moon remembers. The Moon is silent. Its surface tells a story billions of years old, cratered, scarred, unforgiving. Yet, hidden among the chaos are strange patterns, straight lines, perfect circles, grid-like arrangements, features that defy natural expectations. Some appear in high-resolution orbital photographs, captured by multiple missions over decades. Most scientists assume natural origins, volcanism, impacts, lava flows, yet some structures resist conventional explanations. Repeated observations show geometry too precise to be random. The lunar far side is especially mysterious, permanently hidden from Earth, pristine surface, minimal human interference, oldest crust in the solar system. If evidence of Earth's ancient civilizations exists, this is the place to look. Computer simulations show that asteroid impacts scatter Earth material across the Moon. Some fragments could contain technological artifacts, buried, protected, hidden beneath meters of regolith. The geometric anomalies might mark locations where material landed or where it was deliberately placed. Straight ridges extend for miles. Circular depressions exhibit diameters consistent across multiple images. Angles meet with unexpected precision. Some patterns resemble architectural layouts. Could they be the work of intelligence? Satellite imaging has revealed clusters of features. Some align with craters. Others seem independent. If natural, why are they so regular? Why do certain shapes repeat across vast distances? Questions mount. The Apollo missions sampled less than 10 pounds of lunar soil from 6 small areas. Most of the Moon remains untouched. Random sampling makes discovery of anomalies statistically unlikely. China's Chang'e missions have begun mapping the far side. Orbital imagery reveals additional irregularities. Patterns visible from orbit hint at structures that may extend underground. Subsurface radar scans suggest cavities and tunnels in unexpected locations. Potential preservation of artifacts or evidence of past activity. Detection challenges are immense. Lunar geology is harsh. Micrometeorites constantly bombard the surface. Solar radiation alters material. Windless, weatherless, yet relentless space weather shapes the regolith. Still, artificial structures could survive. Buried fragments shielded from radiation. Dense materials maintain shape under micrometeorite impacts. Geometric arrangements resist collapse in ways random formations do not. Artificial signatures might be subtle. Tool marks invisible to orbital cameras. Metallic concentrations undetectable without sampling. Yet patterns hint at intelligence. The moon may be the ultimate archive, a natural vault preserving Earth's history, including technological civilizations that have vanished from our planet. Geometric anomalies could be breadcrumbs left behind, or mere coincidences, but coincidences rarely repeat with perfect angles. Future missions could investigate systematically. High-resolution orbital mapping, subsurface probing, targeted sample return, even remote sensing spectroscopy could detect chemical anomalies. Every anomaly, every line, every circle is a clue. The moon remembers what Earth forgets. Geometric precision may hide in plain sight. Artificial or natural? The answer could rewrite human understanding of history. The silent surface holds secrets billions of years old. Intelligence might have left traces here before humans even existed. We've only just begun to look. The Earth keeps secrets, not just in caves or buried ruins, but deep inside its rocks. Technofossils, artificial remnants preserved in geological formations, could change everything we know about history. Think fossils, shells, bones, plants. They tell the story of life. Technofossils tell the story of intelligence. Manufactured materials, construction debris, even pollution signatures, all locked in stone, ice, and sediment. Humanity has created its first technofossil layer: plastic fragments, concrete foundations, metal artifacts. Radioactive isotopes mark a clear boundary in the geological record. Artificial modification replaces natural processes. Our industrial age leaves traces that will survive millions of years, but humans might not be the first. Previous civilizations could have left similar technofossils, buried deep, altered beyond easy recognition. Their artifacts might not look like anything we expect. Detection is tricky. We assume ancient intelligence used materials like ours. But what if they didn't? What if their metals, ceramics, or polymers were unlike anything we know today? Even the most advanced human technofossils are already challenging to distinguish. Patterns can help. Geometric arrangements in rock, perfect circles, straight lines, regular grids. Mathematical precision rarely happens naturally. Tool marks, crystalline alignment, molecular structures, these can reveal artificial origin. Chemical analysis is vital. Mass spectrometry, isotope ratios, elemental anomalies. Manufactured materials often leave signatures that nature cannot replicate. Even if the object has eroded, chemical fingerprints remain. Technofossils can form like regular fossils. Rapid burial, sediment compression, mineralization, waste from ancient factories, structures buried in mudslides, pollution trapped in ice cores or lake sediments. Urban environments amplify technofossil formation. Foundations, tunnels, roads, and buried utilities alter local geology permanently. Even after surface structures erode, the geological imprint persists. Extreme materials survive best. Titanium alloys, carbon composites, ceramic heat shields. These resist degradation far longer than conventional metals or organics. A fragment of spacecraft or machinery could outlast entire civilizations. Yet, survival isn't enough. Environmental forces, erosion, tectonics, chemical reactions destroy evidence over time. Ideal preservation requires protective conditions: caves, deep sedimentary layers, polar ice, deserts, or buried volcanic deposits. Interdisciplinary collaboration is essential. Geologists, archaeologists, materials, scientists, chemists. We need specialists who understand both natural processes and artificial signatures. The reward is enormous. Technofossils could confirm that Earth has seen intelligence rise and fall before humans. They could provide insight into materials, technologies, and strategies of past civilizations. Even survival tactics and societal organization might be inferred from their industrial traces. This is archaeology on a planetary scale. Millions of years. Geological time. Traditional fossils record life. Technofossils record intelligence. Humanity is just beginning to read the story. The search is a race against time. Natural processes continue to erase evidence daily. We must identify the materials, understand the signatures, and search strategically. What survives will teach us about the past and warn us about the future. The Earth remembers. Technofossils are the key. They might be buried beneath layers of rock, hidden in ice, or scattered across deserts. Our challenge: find them before geology claims them forever. Ancient intelligence may have walked this planet long before humans. Their footprints, if they exist, are etched in stone. Technofossils are the clues. The next frontier of archaeology is here. Earth doesn't keep secrets easily. It's a relentless recycler. Every mountain, valley, and ocean floor is part of a system that erases history. Plate tectonics is the first eraser. Continents drift slowly, inches per year. Collisions crumple landscapes into mountain ranges. Coastal regions are subducted into molten mantle. Entire civilizations, if they existed, could vanish without a trace. Ocean floors are even faster. New crust forms at mid-ocean ridges. Old crust is destroyed at subduction zones. The oldest oceanic crust is only 200 million years old. If ancient coastal civilizations existed, the ocean swallowed them long ago. Erosion adds another layer of destruction. Wind, water, ice, chemical weathering. Even the largest stone structures crumble over millions of years. The Egyptian pyramids, just 40 years old, already show significant wear. Now imagine structures tens of millions of years old. Sedimentation buries the past. Rivers carry soil, sand, and silt from highlands to lowlands. Sediment layers can reach thousands of feet over millions of years. Entire cities, landscapes, and monuments could be compressed into solid rock. Burial preserves sometimes, but often it hides the evidence beyond recognition. Glaciers are unstoppable erasers. Ice sheets hundreds of meters thick scrape landscapes clean. They grind bedrock into powder and carry it hundreds of miles. North America and Europe have seen repeated glacial cycles. Everything in their path, artificial or natural, is reshaped or obliterated. Volcanic activity is the ultimate cover-up. Lava flows bury valleys and towns. Ash deposits change soil chemistry and obscure previous formations. Hot gases, acid rain, and hydrothermal activity alter everything they touch. Volcanic provinces, like the Siberian Traps, covered areas larger than modern countries. Millions of years of history could be locked under solidified lava. Climate accelerates destruction. Rainfall, temperature swings, freeze-thaw cycles all break down structures. Even massive concrete or stone can be shattered by nature. Coastal regions face constant sea level changes, flooding, and erosion. Biology doesn't help either. Plants and trees grow roots that crack foundations. Bacteria decompose organic matter. Ecosystems reclaim abandoned areas. Cities and industrial sites disappear under vegetation over decades or centuries. Time magnifies all these forces. Processes slow to us millimeters per year become unstoppable over millions. Geological recycling is patient. It doesn't care about human achievement. It erases everything, eventually. Understanding this is key to the search for ancient civilizations. We can't rely on surface evidence alone. Subsurface exploration, deep drilling, and sediment analysis become essential. Only protected environments, caves, deep oceans, polar ice, and volcanic ash layers offer hope for preservation. Earth is a masterful editor. It rewrites history constantly. Every mountain range, ocean trench, and lava plateau carries traces of erasure. Civilizations rise, fall, and disappear, not just from wars or neglect, but from planetary forces beyond control. The lesson is clear. If advanced species existed millions of years ago, their footprints are gone. Almost everything they built, mined, or manufactured has been recycled. Finding evidence requires looking for anomalies in places geology can't easily erase. Earth isn't hostile, it's just efficient. It recycles everything: plate tectonics, erosion, volcanism, glaciers, climate, biology, all work together to hide history. The Earth remembers, but only in fragments, deep layers, and protected corners. Searching for ancient civilizations isn't about walking the surface. It's about understanding Earth's recycling machinery. It's about finding where the planet can't reach. Only there might technofossils, artifacts, and anomalies survive. History isn't lost, it's hidden. Earth just makes us work for it. Earth has a secret weapon: sediment. Rivers, glaciers, and wind constantly move it around. Mountains erode, valleys fill, coastlines shift. Entire civilizations could vanish beneath layers of rock and soil. Rivers are relentless. They carry sediments from mountains to oceans. Every rainstorm, flood, and mudslide adds material to the flow. Sand, silt, clay, and organic debris pile up over centuries. Over millions of years, these layers compress into rock. Buildings, roads, even entire cities could become fossilized in sediment. Think of deltas and floodplains. The Nile, Mississippi, and Ganges deposit thousands of cubic kilometers of material every century. Structures built along rivers are particularly vulnerable. Civilizations that thrived by waterways, like the Indus Valley or Mesopotamia, might leave minimal traces after millions of years. Glaciers add another layer of erasure. Ice sheets scrape and grind everything beneath them. Bedrock becomes powder, carried miles away. Sediment transported by glaciers, till, moraine, and glacial deposits covers valleys and plains. Even entire mountain villages could disappear under glacial sediment. Subsequent glacial melting doesn't restore the past. It leaves behind new sediment layers, reshaping rivers, lakes, and coastlines. A city buried by glaciers could be hidden under hundreds of feet of moraine. The footprint is there, but invisible without deep drilling or remote sensing. Sedimentary burial isn't uniform. Some regions accumulate layers faster than others. Floodplains, deltas, and shallow seas are hotspots. Ancient coastal civilizations are particularly vulnerable. Sea level changes over geological time add complexity. Rising oceans flood coastal settlements. Sediment from tides, storms, and erosion covers remains quickly. Volcanic ash layers interact with sediment. Eruptions deposit massive amounts of tephra over cities and forests. These ash layers can act as protective blankets, preserving artifacts, or as destructive forces, burying and reshaping landscapes entirely. The same ash that preserves Pompeii also erases pre-existing structures beneath. Erosion works simultaneously with burial. Rain, wind, and glaciers move sediments constantly. Old surfaces are buried while new ones form. The more time passes, the deeper the layers. Civilizations that lasted thousands of years might be reduced to fragments within tens of meters of rock. Sedimentary burial explains why we find only fragments of ancient life. Fossils favor rapid burial animals near rivers, shells in shallow seas. Artificial structures aren't lucky. Stone can survive, but wood, textiles, and plastics decay before burial is complete. Even metals corrode if exposed to moisture and chemicals before being sealed. Human understanding is limited. We dig carefully at archaeological sites, expecting to find ruins. But Earth doesn't preserve history like a museum. It buries, mixes, and hides it beneath kilometers of sediment. Remote sensing, core sampling, and deep drilling are necessary to detect what lies below. The key insight: rivers and glaciers are history's editors. They hide entire landscapes. Civilizations that thrived along waterways may leave almost nothing visible. Ice Age advances and retreats erase more than they preserve. Geology writes and rewrites, layer by layer, century by century, million by million. Sedimentary burial teaches a lesson. Searching for ancient civilizations isn't just about ruins on the surface. It's about understanding Earth's natural layering. It's about looking in the right depth, reading the right signals, and knowing where the planet has hidden its secrets. History isn't destroyed, it's buried, and the deeper we look, the more we might discover. Time is ruthless. Materials don't last forever. Wood rots, metals corrode, plastics break down, and soft tissues vanish. Even the strongest structures crumble under the pressure of nature. Wood is fragile. Exposure to air, moisture, and microorganisms accelerates decay. Termites, fungi, and bacteria eat it away from the inside out. A wooden house from 1,000 years ago? Gone. Buried quickly in sediment, it might survive a bit longer. But left on the surface, it disappears within decades. Metals aren't immune. Iron rusts when it meets water and oxygen. Copper, bronze, and other alloys corrode over centuries. Salt water is merciless. Ships, tools, and bridges can vanish in a few hundred years. Even stainless steel, considered durable, succumbs to slow chemical reactions over millennia. Soft tissues decay fastest. Muscles, organs, skin, they're gone within decades without extreme preservation. Mummification, freezing, or anaerobic environments can slow this, but it's rare. Even in ideal conditions, organic material rarely lasts millions of years. Plastics, surprisingly, aren't eternal either. Sunlight, oxygen, and microorganisms break polymers down. Microplastics remain, but the original form is lost. Industrial materials that humans consider durable aren't safe on geological timescales. Stone survives longer, but even it isn't invincible. Weathering, erosion, and tectonic forces wear down monuments. Granite lasts longer than wood, but tool marks fade, carved inscriptions blur. Natural forces erase human touch, slowly but relentlessly. Climate accelerates decay. Heat, cold, wind, rain, and freeze-thaw cycles crack and crumble surfaces. Volcanic activity can bury and preserve, or melt and destroy. Floods can wash away entire towns. Glaciers grind cities into powder. Time magnifies destruction. What seems slow on human scales becomes unstoppable over millions of years. A civilization's artifacts, no matter how advanced, face inevitable decay. Only exceptionally durable materials or rare conditions can preserve traces. Understanding decay explains why searching for ancient civilizations is so hard. Wood, fabric, plastics, and flesh vanish quickly. Metals corrode and crumble. Even stone loses clarity over millennia. The Earth erases evidence faster than humans can record it. Yet, decay isn't absolute. Rapid burial, extreme cold, dry deserts, and underwater conditions can preserve remnants. Some materials resist chemical breakdown. Ceramics, glass, and certain alloys survive longer. But survival depends on environment as much as material. The takeaway: most of what civilizations build is temporary. Time, nature, and chemistry ensure that only fragments persist. Soft, organic, and common materials vanish. The Earth becomes a vast archive where only select traces endure. Decayed materials aren't just gone, they shape what we can discover. Searching for the past means knowing what survives and where. It means looking beyond wood, metals, and plastics. It means understanding that decay is the rule, not the exception. History is fragile. Time is the ultimate eraser. Earth is ancient, 4 billion years old. Mountains rise and crumble. Oceans form and vanish. Continents drift like puzzle pieces over eons. Human civilization? Tiny. Agriculture emerged 0 years ago. Industrial technology? Barely 200 years old. Our entire recorded history is a fraction less than 0.002% of Earth's life. If Earth's history were a single year, human civilization occupies the last few seconds before midnight on December 31st. Every empire, every invention, every war, just a blink. Geological time doesn't notice us. Millions of years are the norm. Slow, relentless forces shape the planet. Mountains erode. Rivers carve valleys. Tectonic plates collide and subduct land into molten mantle. Our cities would vanish in such scales. Stone, metal, even concrete would disappear. Extinction events are bigger than humans. Asteroids strike. Volcanoes erupt. Climate shifts wipe ecosystems. Civilizations could have arisen and fallen without leaving a trace. Entire intelligent species could have lived and died before humans even appeared. Timescales hide history. Soft tissues decay in decades. Metals corrode in centuries. Wood rots in decades. Even stone erodes over millennia. The Earth systematically erases everything. The fossil record is biased. Hard shells and bones survive best. Soft creatures and fragile artifacts? Almost never. Technological remnants decay even faster. Plastic, electronics, and machinery break down. Millions of years reduce civilizations to whispers in the rock layers. Think statistically, if civilizations emerged randomly over 4 billion years, dozens could have risen and vanished without overlap. Chances of finding their remains? Minuscule. The universe might be filled with silent, lost histories. Even surviving artifacts may be unrecognizable. Tool marks fade, geometric patterns blur. Isotopes mix with natural background. What we expect as evidence might not match what ancient species left behind. Geological perspective changes everything. Our sense of long ago is irrelevant. Thousands of years is a heartbeat. Millions is a blur. Billions is incomprehensible. Yet, some traces endure. Diamond, ceramics, and certain alloys resist time. Deep oceans, frozen ice, deserts, and caves can preserve materials. Rare conditions allow whispers of ancient intelligence to survive. The challenge is enormous. We must consider time not as human years, but as eons. Finding civilizations in geological history is like spotting a single grain of sand on a continent. Humanity is tiny. Our technology, art, and cities are fleeting. Earth has seen more rise and fall than we can imagine. We are a blink, a flash in the deep time story. The question, will our civilization leave a mark that survives millions of years? Or will we vanish as countless others have? Geological time doesn't wait. Not all materials vanish equally. Some resist time like warriors against decay. Diamond, nature's hardest substance, chemically inert, unyielding under pressure. It can survive billions of years. Industrial diamonds? Tools, blades, they could persist virtually forever. Even the harshest geological processes barely scratch them. Ceramics, silicon carbide, titanium carbide, advanced engineering ceramics. They resist corrosion, weathering, chemical breakdown. Thousands, even millions of years may pass, yet their structure holds. Stone crumbles, metals rust, ceramics endure. Artifacts made from these could carry traces of intelligence. Metallic glasses, rapidly cooled alloys, no grain boundaries, uniform atomic structure. Oxidation struggles to penetrate. Corrosion slows. These amorphous metals could survive conditions that destroy conventional alloys. Ancient civilizations with advanced metallurgy, they might leave these behind. Nanomaterials, diamond-like carbon coatings, ferroene structures, molecular scale manufacturing, tiny but remarkably durable. Engineered at the atomic level, they resist chemical reactions, abrasion, and thermal cycling. Potential to survive millions of years, even in hostile environments. Composites combine strengths. Carbon fiber reinforced ceramics. Metal matrix composites. Hybrid materials designed for aerospace or extreme conditions. They retain recognizable structure where ordinary materials fail. A lost civilization could leave messages in these enduring forms. Preservation isn't just about strength. Placement matters. Deep burial protects against weather, oxidation, abrasion. Polar ice slows chemical reactions. Deserts limit rainfall damage. Volcanic ash or rapid sedimentation can entomb objects instantly. Yet, durability isn't invincible. Tectonic crushing, thermal cycling, erosive transport. Even diamonds can succumb if exposed to extreme conditions. Time is relentless. Ancient intelligence might have known this. Perhaps they designed their most important artifacts to survive. Hidden in stable locations, constructed with the toughest materials available. Messages to the future. Think beyond stone and metal. Molecular precision, geometric perfection, chemical stability. The artifacts we overlook today might be the last survivors of civilizations lost to geological time. Durable materials extend our search window. Where ordinary artifacts decay within centuries or millennia, advanced substances could survive millions of years. They offer a clue. Intelligence may leave traces if it anticipates time. The question, did ancient civilizations think in geological time? Did they deliberately preserve knowledge for the far future? Diamonds, ceramics, metallic glasses, and nanomaterials may be the key. They could be the whisper of intelligence still waiting to be discovered. Not all places are equal. Some environments fight time. They protect, they preserve, they hide. Caves, nature's vaults, stable temperatures, minimal oxygen, shielded from wind and rain. Artifacts buried deep remain safe from decay. Even soft materials, wood, textiles, organics stand a chance here. Geological stability matters. Few earthquakes, minimal water flow. A civilization's tools, records, or even messages could survive tens of thousands of years. Deserts, dry, arid, harsh to life, but gentle to artifacts. Rain rarely touches the ground. Oxidation slows. Microbial decay almost stops. Sunlight can bleach surfaces, but buried structures endure. Think stone ruins, metal tools, or ceramics encased in sand. Time moves slowly here, letting traces persist almost indefinitely. Polar regions. Ice is a natural freezer. Temperatures plunge. Chemical reactions crawl. Organic materials don't rot. Buried under glaciers or permafrost, artifacts can survive for millions of years. Even subtle traces, DNA, metals, unusual minerals remain intact. Antarctica and the Arctic might guard secrets from pre-human civilizations. Ice cores, subglacial lakes, frozen tunnels, potential time capsules, deep oceans, cold, dark, low oxygen. Sediment blankets protect the floor. Currents are slow, light doesn't reach. Organic decay slows. Metal corrosion still happens, but far less than on the surface. Hydrothermal vents, complex ecosystems exist, but human artifacts could lie untouched nearby. Vastness matters. Millions of square miles remain unexplored. Even a single preserved site could rewrite history. Optimal preservation combines material and environment. Durable substances placed in protective locations last far longer. Diamonds, ceramics, metallic glasses, and engineered composites find their best chance in these shelters. The environment amplifies their longevity. The planet has natural vaults. Caves, deserts, polar ice, and deep oceans act like storage units across geological time. If ancient civilizations understood these principles, they could have deliberately hidden their most important objects. Messages for the far future. Technological records. Knowledge too advanced for survivors of later ages. The search must focus on these locations. Surface excavation won't cut it. Targeted, high-tech exploration of natural preservation zones is key. Satellites, submersibles, drilling rigs, these tools can probe hidden realms. The evidence is there, waiting, but time is still relentless. Even these vaults aren't invincible. Climate change, shifting sediments, melting ice, modern forces threaten these natural archives. The question is urgent. What might we discover before the planet erases it forever? Subscribe now to follow the journey. Explore hidden civilizations, ancient technologies, and the secrets Earth has buried for millions of years. Durability isn't just luck, it can be designed. Some materials survive millions of years. Diamonds, ceramics, metallic glasses, nanomaterials built to endure. Could ancient civilizations have known this? Could they have deliberately engineered their artifacts for longevity? Think about it. A society aware of geological timescales could predict decay, erosion, and tectonic upheavals. They might select materials resistant to corrosion, chemical reactions, and mechanical stress. They could bury objects in caves, polar ice, or deep ocean sediments for protection. They could craft messages meant to survive long after humans vanish. The principle is simple: durable materials plus protective environments, survival over millions of years. Diamonds carved into tools or symbolic shapes could survive almost anything. Advanced ceramics withstand heat, pressure, and chemical degradation. Metallic glasses resist oxidation better than normal metals. Nanostructured materials could maintain integrity indefinitely. Some artifacts might have combined materials. Stone frameworks reinforced with ceramic coatings. Metal alloys encased in resistant polymers. Composites designed to maintain structural and chemical integrity over eons. Placement matters. Burial in sediment slows oxidation and shields from physical damage. Caves offer constant temperatures and low humidity. Deserts limit water-induced corrosion. Ice preserves organics. Deep oceans minimize light and oxygen exposure. Could ancient civilizations have used these strategies? It's plausible. Messages, records, tools, or even technological prototypes might have been intentionally hidden, where time itself becomes an ally. Evidence today might be subtle. Geometric formations in stone, unusual isotopes in ice cores, metallic fragments buried deep. These could all be remnants of intentional design. Artificial longevity leaves traces, but often in ways that require advanced detection methods. The implications are huge. If civilizations intentionally engineered longevity, some of their artifacts could still exist, waiting to be found. We may only need the right combination of material science, archaeology, and geophysics to uncover them. The concept changes how we search. Not every artifact is on the surface. Not every trace is obvious. Some survive by design, hidden in the most extreme, stable environments. Some messages may last longer than the civilizations that created them. Artificial longevity isn't science fiction. It's a strategy, and if ancient civilizations understood it, we may be closer to discovering their hidden legacies than we realize. Time is relentless, but design can fight time, and some traces might still be waiting for us to uncover them. Civilizations leave fingerprints, not just in ruins, but in energy use. Burning fuel, smelting metals, generating power all create lasting traces. Fossil fuels are easy to spot. Coal, oil, and natural gas carry unique carbon isotope signatures. When burned, they release carbon dioxide with ratios distinct from natural processes. Millions of years later, this signature remains in sediments, ice cores, and rocks. It's a geological whisper of industrial activity. Metal smelting leaves marks too. Lead, copper, tin, iron, processed at scale, they pollute air and water. Particles settle in lake beds, peat bogs, and ice layers. Roman mining operations? Detectable in Greenland ice cores, 0 years later. Smelting isn't just industry, it's a time capsule. Nuclear energy leaves the most stubborn trace. Uranium enrichment, plutonium production, atomic testing. Radioactive isotopes appear in ice cores, soil, and sediments. Some isotopes survive millions of years. The Trinity test in 1945 created trinitite glass, preserving the exact moment humans harnessed nuclear power. If ancient civilizations had nuclear tech, their traces could linger just as long. Advanced technologies might leave subtler markers. Fusion power changes helium isotope ratios. Antimatter annihilation produces gamma rays. Zero-point energy or exotic tech could leave signatures we don't yet recognize. The absence of expected traces could mean the civilization was efficient or used energy sources beyond our understanding. Construction alters geology too. Massive quarries, dam projects, urban centers, they compact soil, shift sediment, and create patterns visible millions of years later. Even vanished cities leave fingerprints in the rock. Climate interventions, terraforming, or large-scale ecosystem management. These create energy markers measurable on planetary scales. Atmospheric composition, ocean chemistry, or sediment distribution can encode decades or millennia of artificial activity. Detection isn't easy. Geological surveys usually focus on natural processes. Technological signatures from unknown civilizations require new methods and interdisciplinary research. Geochemistry, isotope analysis, and sedimentology become archaeology tools. Energy signatures are proof of activity even if structures vanish. They can indicate industrial, scientific, or technological civilizations long erased by time. Like footprints in stone, these traces hint at the scale, sophistication, and survival strategies of long-lost societies. Looking for these markers rewrites archaeology. It's no longer just about ruins or artifacts. It's about reading the planet itself. The rocks, ice, and sediments keep score. They record energy use, technological feats, and industrial life across eons. If we learn to read these signatures, we might uncover civilizations older than history, hidden not in ruins, but in the very chemistry of Earth itself. Civilizations leave marks invisible to the naked eye. Energy use, industry, technology, they all imprint the Earth. Carbon tells a story. Fossil fuels contain a unique carbon signature. Burn them, and the atmosphere changes. Carbon-12 and carbon-13 ratios shift. This shift gets trapped in sediments, tree rings, and ice. Thousands, even millions of years later, scientists can detect it. It's a fingerprint of industrial activity. Pollution is another marker. Metal smelting releases lead, copper, tin, and iron particles. These metals travel through air and water. They settle in lakes, bogs, and ice cores. Roman mining, still visible in Greenland ice. Industrial pollution accumulates layer by layer. Each sediment layer is a snapshot of human or pre-human activity. Radioactive layers are the ultimate time capsules. Nuclear fission leaves isotopes with half-lives spanning millions of years. Uranium, plutonium, cesium, each has a signature decay pattern. The Trinity test in 1945 created trinitite, a glass preserving the explosion. Ancient civilizations using nuclear tech would leave similar traces. These isotopes survive long after buildings crumble and cities vanish. Even industrial chemistry leaves traces. Synthetic compounds, heavy metals, and rare elements resist degradation. They accumulate in sediment layers. They reveal large-scale manufacturing or technological activity. Sediments act like archives. Rivers, lakes, oceans, they trap materials over time. Volcanic ash layers, glacial deposits, desert sands, they preserve chemicals. Each layer can reveal energy use, pollution events, and industrial intensity. Carbon isotopes, metals, and radiation together tell a story. It's a history written in chemistry rather than stone. Even when physical structures are gone, these markers persist. They outlast cities, monuments, and roads. They endure the processes that erase most other evidence. Detecting these fingerprints requires advanced science. Mass spectrometry identifies isotopes and elemental ratios. Chemical analysis spots synthetic compounds. Sediment core sampling reconstructs a timeline. Patterns emerge: spikes in pollution, shifts in carbon ratios, radioactive anomalies. Each anomaly suggests activity far beyond natural processes. Some markers might indicate environmental impact. Rapid industrialization changes soil composition. River chemistry shifts. Ocean currents carry new elements to remote areas. Even the atmosphere holds a chemical memory. The absence of expected markers is also revealing. If a civilization existed but left no detectable isotopes, it might have been energy efficient. Or it might have used technologies we can't recognize yet. Either way, sediments hold clues waiting to be read. Industrial fingerprints redefine archaeology. It's not just ruins and artifacts anymore. It's about reading Earth's chemistry. Rocks, ice, soil, and sediments are archives of activity. They record energy use, technology, and industrial behavior across eons. If ancient civilizations existed, these fingerprints could be their legacy. Even without monuments, cities, or machines, the planet remembers. And the deeper we dig, the more secrets we might uncover. Nature doesn't negotiate. Volcanoes erupt, asteroids strike, greenhouse effects spiral out of control. Volcanic eruptions can reshape worlds. Mountains blow apart, ash blankets continents. Skies darken for years. Photosynthesis stops. Food chains collapse. Ancient civilizations, relying on agriculture, face starvation. Mass extinctions leave few survivors. Asteroid impacts are even more sudden. One strike releases energy equivalent to billions of nuclear bombs. The dinosaurs learned this lesson 66 million years ago. Fireballs, shockwaves, earthquakes. Tsunamis sweep across coasts. Global cooling follows from dust blocking sunlight. Any civilizations in the path? Wiped out instantly. Runaway greenhouse effects are slower, but relentless. Temperatures rise, oceans evaporate, atmospheres thicken, water escapes to space. Venus shows what happens when feedback loops run unchecked. Ancient Earth may have experienced smaller, localized events. Civilizations built near tipping points faced slow doom. Evidence hides in the geological record. Ash layers, iridium spikes, and shocked quartz mark asteroid impacts. Lava flows, sulfur deposits, and ash beds signal massive eruptions. Carbon isotope ratios shift during runaway greenhouse events. Ice cores reveal sudden warming or cooling periods. Civilizations are fragile. They rely on stable environments. Crop cycles, water supply, trade routes, all are vulnerable. A rapid climate event can collapse even advanced societies. Floods, droughts, and temperature swings overwhelm infrastructure. Repetition matters. These events didn't happen once. Volcanic supereruptions occurred every few million years. Asteroid impacts happen roughly every 20-50 million years. Runaway climate episodes could recur when conditions aligned. Patterns emerge. Many mass extinctions coincide with abrupt environmental changes. technological civilizations might have risen and fallen before humans, their traces erased by ash, rock, ice, and ocean currents. Modern humans face similar risks. Climate change accelerates, ice sheets melt, oceans acidify, extreme weather intensifies. The past is a warning. Understanding ancient climate collapses helps today. We can identify tipping points. We can recognize environmental stresses. We can learn how civilizations failed and survive. The geological record is a library. Ash, sediment, ice, and rock preserve the memory of catastrophe. Civilizations may vanish, but nature remembers. To uncover them, we read the signatures left behind. The question remains, did advanced civilizations fall during these cataclysms? If so, how many? The evidence might be subtle, but it exists, hidden in Earth's climate memory. Space is not friendly. Asteroids roam the solar system. Some are small, harmless. Others carry enough energy to wipe out civilizations. When a massive asteroid hits Earth, it acts like a reset button. It erases everything in its path. Cities vaporize, forests ignite, oceans churn. The dinosaurs experienced this 66 million years ago. A single asteroid ended 160 million years of dominance. Shockwaves, firestorms, tsunamis, dust blocked sunlight for months. Photosynthesis stopped. Ecosystems collapsed. Life survived, but civilizations? Non-existent. Smaller impacts can destroy regional societies. A 1-6-mile asteroid can annihilate a continent. Infrastructure crumbles. Famine spreads. Population collapses. These events are not random in their effects. They hit frequently enough to prevent long-term technological progress. Civilizations need stability. They need centuries, even millennia, to develop space travel, energy management, and advanced technologies. An asteroid strike cuts this short. The late heavy bombardment shows the early solar system was chaotic. Impacts hundreds of times more frequent than today-shaped planetary surfaces. Early life and civilizations, if any existed, faced near constant extinction risk. Even advanced civilizations are vulnerable. Nuclear weapons might deflect small objects, but multi-mile asteroids carry too much momentum. No current technology can reliably stop them. If past civilizations reached advanced stages, asteroid impacts may have wiped them out before they could expand into space. Cosmic catastrophes also shape evolution. They remove dominant species. They open niches for survivors. Life adapts. Intelligence emerges again. But technological progress often resets. Statistical analysis suggests large civilization-ending impacts occur every 20-50 million years. Smaller, regional devastation happens more frequently. Earth's history is marked by repeated resets. Civilizations may have risen and fallen multiple times without leaving clear traces. The pattern is brutal. Intelligence evolves slowly, so asteroids strike faster than adaptation or defense. Civilizations rise, flourish briefly, then vanish. Understanding cosmic resets is key to our survival. Predicting asteroid paths, deflecting potential threats, learning from past cycles. The universe doesn't forgive mistakes. The Earth's geological record holds clues. Impact craters, shocked minerals, and ejecta layers preserve evidence of ancient catastrophes. Civilizations may have disappeared, but their timing aligns with these cosmic events. Asteroids are silent, invisible executioners. They reset the stage. Life adapts. Civilizations start over. The past warns us: survive long enough or be erased by the cosmos. Extinction shapes life. It destroys the weak. It clears space for the adaptable. Mass extinctions reset evolution. After a catastrophe, ecosystems are empty. Niches are open. Competition drops. Resources abound. Intelligence evolves faster in these conditions. With predators gone, food abundant, and pressure to survive high, cognitive skills provide an advantage. Species that can plan, communicate, or manipulate their environment thrive. The dinosaurs' extinction is a prime example. Mammals were small, hidden, and weak, but in the aftermath, they exploded in diversity. Brains grew, complex behaviors emerged. Within tens of millions of years, intelligence had a real chance to develop. Other extinction events show similar patterns. The Permian-Triassic wiped out 96% of marine species. Survivors faced harsh conditions. They adapted quickly. Rapid evolution favored problem solvers, tool users, and opportunists. Extinction events create evolutionary pressure like a furnace. Only the flexible survive. Those with intelligence gain an edge. Cognition becomes a survival tool. Technology, if developed, would follow naturally. Repeated catastrophes could explain why intelligence appears in bursts. Civilizations rise, hit limits, and vanish. Gaps exist in the fossil and geological record. Maybe advanced species came before humans, only to be wiped out by cosmic or environmental disasters. This could also explain the sudden acceleration of human intelligence. After multiple bottlenecks, surviving populations had concentrated knowledge. Pressure to survive pushed cognitive development faster than normal evolution. Rapid problem solving became a necessity. Evolutionary pressure doesn't guarantee civilization. It only favors traits that survive. Tools, language, planning, and social organization may appear, but environmental threats can stop progress in its tracks. Patterns suggest intelligence is cyclical. Rise, flourish, collapse, then rise again. Each reset teaches survival lessons, encoded in genetics, behavior, or culture. Understanding these cycles could help humanity. We face our own mass extinction risks. Climate change, nuclear threats, asteroids. The same pressures ancient species faced. We must adapt faster. Learn from evolution's past experiments. Survival favors intelligence under pressure. Extinctions are brutal teachers. They reward flexibility, foresight, and problem solving. Civilizations that survive learn to navigate catastrophe. Those that fail vanish without a trace. The history of life is written in cycles of destruction and adaptation. Each catastrophe reshapes the rules. Intelligence emerges rapidly when opportunity meets necessity. Perhaps humans are just the latest surge in a long pattern. Stories survive longer than cities. Legends outlive empires. Oral traditions carry memories across generations. Some myths hint at advanced knowledge. Hindu epics describe flying machines, immense weapons, and communication devices. Greek tales speak of golden ages with humans living alongside godlike beings. Native American traditions tell of previous worlds destroyed when inhabitants grew too advanced. These stories may preserve more than imagination. They could encode real events. Knowledge survived when civilizations vanished. Catastrophes destroyed the physical, but memory endured in narrative. Oral transmission is powerful. Stories travel through centuries. They adapt, but core truths persist. Cultural memory becomes a time capsule. Advanced skills in ancient societies sometimes appear suddenly. Precision stone cutting, astronomical alignments, engineering that should be impossible for hunter-gatherers. Mythology could provide clues. Perhaps these achievements were inherited fragments of older traditions. Civilizations rise and fall. Knowledge is lost, hidden, or partially remembered. Libraries burn, cities collapse. Yet stories, songs, and rituals continue. They carry subtle hints of ancient technologies and techniques. Some myths describe tools, machines, and concepts we recognize only today. Flying vehicles resemble aircraft. Weapons match descriptions of modern artillery. Communication devices, parallel radios. Could these be symbolic or literal memories? Population bottlenecks reinforce this memory survival. After catastrophic events, survivors retain fragments of previous knowledge. Small groups safeguard skills, stories, and practices. Oral tradition becomes critical for continuity. Hidden repositories are part of many myths. Secret libraries, underground facilities, lost caches, knowledge protected for rediscovery. These tales may reflect real strategies to preserve civilization's wisdom. Human progress might not always be linear. We could be rediscovering what was lost before. Mathematics, architecture, metallurgy, and astronomy may have older roots than we assume. Mythology also warns. Stories of hubris, destruction, and divine retribution might encode lessons from past collapses. Environmental mismanagement, warfare, and technological misuse appear repeatedly. Civilizations that failed left cautionary tales for those who followed. Understanding these narratives is crucial. They might reveal cycles of human development and collapse. Cultural memory becomes a bridge to forgotten civilizations. It hints at what humans once knew. It also shows what might be lost again if ignored. The echoes of lost knowledge are everywhere. Legends, epics, and myths are more than entertainment. They are historical signals, fragments of intelligence that survived catastrophe. Decoding them may help humanity avoid repeating ancient mistakes. And maybe, just maybe, they point toward technologies and wisdom waiting to be reclaimed. Our genes tell stories older than written history. They carry records of survival. DNA preserves echoes of population crashes. Genetic studies reveal bottlenecks. Times when humans dwindled to fewer than 0 individuals. Entire populations nearly vanished. Some bottlenecks coincide with massive natural disasters. Volcanic eruptions, asteroid impacts, climate extremes, catastrophic events erased entire societies. These collapses shape our evolution. They reduce diversity. They force adaptation. They create lineages that survive against the odds. Population bottlenecks are not rare. They occurred multiple times over the last 100 years. Each collapse left a mark on human DNA. Our chromosomes carry these signatures. Genes show reduced variety. Mutations reveal ancient stress events. Some bottlenecks align with known catastrophes. The Toba supervolcano eruption, about 74 years ago. Ash covered thousands of miles. Global temperatures dropped. Survivors were few, scattered, and isolated. Genetic evidence supports this event. Human diversity plummeted. Other collapses are subtler. Climate shifts created resource scarcity. Glacial advances forced migrations. Small groups survived, while larger populations perished. Their DNA becomes the foundation for future generations. Bottlenecks also explain lost knowledge. Civilizations may have existed before these collapses. Technologies, languages, and practices could vanish when populations shrink. Only fragments survive. These fragments could appear later as sudden advances or unexplained achievements. Repeated bottlenecks suggest cycles. Humanity has faced near extinction multiple times. Yet we survived. Our species has resilience coded into our DNA. Genetics also hints at hidden lineages. Populations that diverged evolved in isolation. These groups may have preserved knowledge unknown to others. Their survival could seed rediscovery of lost technology or cultural practices. Understanding these patterns matters today. We face environmental stress, pandemics, and climate change. Studying past bottlenecks can guide preparation. History embedded in our genes teaches survival lessons. Population collapses were not just numbers. They shaped culture, technology, and human potential. Knowledge could disappear with a few thousand survivors. Or it could endure, preserved in myths, stories, and genes. Our DNA is a living archive. It carries evidence of endurance and loss. Bottlenecks are proof humanity has been tested before. Survival was never guaranteed. Yet here we are, facing new challenges. The lessons encoded in our genetic past may be the key to avoiding future collapse. Some ancient texts describe inventions that boggle the mind: flying machines, weapons of immense power, communication devices. Texts from India, Greece, and the Middle East hint at advanced knowledge. The Sanskrit epics are full of mysterious technologies: vimanas, flying chariots that soar through the sky, weapons that unleash massive destructive energy, communication tools capable of transmitting over long distances. Greek and Roman sources are no less intriguing. Accounts of mechanical devices, automata, and advanced warfare. Texts describe machines that seem impossible for their era. Some suggest knowledge imported from older civilizations. Many scholars dismiss these as myths, stories exaggerated by imagination, yet the precision in descriptions is puzzling. They contain technical details beyond the capabilities of the era. Ancient manuscripts often survive by accident, hidden in monasteries, caves, or private libraries. Others are lost forever, destroyed by time, fire, or war. The Library of Alexandria is the ultimate example. Millions of scrolls of accumulated knowledge vanished in an instant. Lost technologies might have existed and disappeared. Aircraft, weapons, and devices described in texts could have been real. They may have required materials or techniques now forgotten, or civilizations may have deliberately concealed them. Some texts hint at hidden repositories, knowledge caches buried in remote locations, guarded by societies aware of their value, perhaps meant to survive catastrophes or societal collapses. Rediscovery of these technologies could explain sudden leaps in human development. Some inventions appear centuries before their modern equivalents. Could these be fragments of older knowledge resurfacing? Perhaps survivors of previous civilizations preserved key technologies. Descriptions often combine practical use and symbolic meaning. Weapons capable of massive destruction might be metaphors. Flying machines may symbolize mastery over nature. Yet, the recurring technical details hint at real applications. Communication devices appear repeatedly, messages transmitted over vast distances. Sounds, symbols, even images conveyed without physical travel. These could reflect understanding of electromagnetic or acoustic principles lost to time. Humanity's rapid technological rise might not be entirely original. Some advances could be recoveries of older capabilities. Invention and rediscovery may be cyclical. Knowledge hidden, lost, and found again over millennia. Ancient texts are more than stories. They are potential blueprints of forgotten technologies. Interpretation is difficult. Cultural context, symbolism, and translation errors complicate understanding. Yet, persistent patterns hint at real devices and systems. The challenge is recognizing technology buried in metaphor. Ancient civilizations may have encoded instructions for survival. For future generations, should disaster erase civilization, the evidence exists in texts, waiting for careful decoding. Lost technologies could illuminate the past. They might reveal civilizations far more advanced than we imagine. If interpreted correctly, they could guide modern innovation or warn us of mistakes that led to extinction in cycles past. Some knowledge survives because it is hidden. Ancient civilizations may have created repositories to preserve wisdom, libraries, vaults, underground facilities, and secret caches, places designed to withstand time, natural disasters, or human interference. The Library of Alexandria is the most famous example. Millions of scrolls disappeared in a single catastrophe. Knowledge lost forever, or at least hidden from us. Other repositories may still exist, untouched. Texts hint at underground vaults. Temples, pyramids, and mountains sometimes conceal chambers. Hidden rooms behind walls. Locked containers buried in deserts or forests. Secrets protected by design and secrecy. Ancient societies understood the fragility of civilization. They may have anticipated floods, wars, or societal collapse. Caches were built to survive millennia. Durable materials, sealed chambers, strategic locations. Some repositories could store practical knowledge, technologies, blueprints, weapon designs, flight systems. Others may contain cultural wisdom, mathematical tables, astronomical charts, and philosophical texts. The Maya, Egyptians, and Sumerians all built secret storage spaces, hidden corridors under temples, stone boxes beneath ceremonial platforms. Vaults beneath pyramids may preserve knowledge yet to be discovered. In remote locations, knowledge caches were easier to protect. Mountains, deserts, ice, and forests provide natural concealment. Access limited to the initiated or trusted members. Some were designed to reveal information only when conditions were right. Cultural traditions often mentioned secret repositories, legends of lost treasures, sacred knowledge, or hidden cities. The Hindu epics describe caches of advanced devices. Greek myths speak of chambers where gods left tools and knowledge. Preservation techniques could have been advanced. Sealed containers to protect from moisture, heat, or decay. Stone, metal, ceramics, and engineered composites may have been used. Locations chosen for stability underground, ice, or desert shelters. Modern archaeology has barely scratched the surface. Most excavations focus on visible structures or artifacts. Subterranean and remote caches remain largely unexplored. Satellite imaging, ground-penetrating radar, and magnetometry could reveal hidden chambers. Knowledge repositories could explain sudden leaps in human development. Civilizations may rediscover old technology, giving the illusion of innovation. Flying machines, precision tools, and energy devices might reappear after centuries of absence. Some caches might have been deliberately lost or abandoned. Political upheavals, wars, or collapses could force secrecy. Societies might hide dangerous technologies from future generations. Weapons, industrial processes, or powerful tools could be locked away intentionally. Oral traditions often point toward hidden knowledge. Stories of mountains with secret entrances, lakes hiding underwater chambers, temples with hidden compartments. The challenge is finding these repositories today. Locations may have shifted over millennia. Erosion, earthquakes, and human activity may conceal entrances. Yet geological and historical clues can guide researchers. Discovering ancient knowledge caches could rewrite history. They might reveal technologies far older than previously thought. Practical wisdom, energy methods, construction techniques, or survival strategies. A single cache could illuminate entire lost civilizations. Humanity stands at a crossroads. If previous civilizations hid knowledge, we might be the first to rediscover it in the modern era. Success could accelerate progress. Failure could mean losing crucial lessons forever. Ancient repositories remain a hidden archive of intelligence. They are silent witnesses to civilizations that rose and fell. Finding them could help us survive and thrive, avoiding mistakes that doomed our predecessors. Civilizations may not be linear. They rise, thrive, and then collapse. Then, the cycle begins again. Earth's history spans billions of years. A blink for humans could hide countless societies before us. Catastrophes reset progress. Asteroids, volcanoes, climate shifts, or floods wipe out entire populations. Technologies vanish. Knowledge disappears. Survivors may retain fragments. Some knowledge may be encoded in myths, legends of golden ages, lost cities, or advanced beings. Stories passed orally, surviving disasters that destroyed libraries and archives. They are cultural fossils, hints of civilizations long gone. Genetic evidence supports this pattern. Population bottlenecks suggest repeated near extinctions. Small groups repopulated Earth after disasters. Lost knowledge could resurface as civilizations rebuilt. Technologies could be rediscovered. Flight, metallurgy, irrigation, or astronomy may appear multiple times. Independent invention may be influenced by residual knowledge. Sometimes inventions appear simultaneously across different regions. Underlying information may persist through hidden repositories or oral tradition. Climate and environment shape these cycles. Rapid changes stress societies. Overpopulation, resource depletion, or ecological collapse trigger decline. Advanced civilizations could fail even with strong technology. Cycles also involve opportunities. Each collapse resets ecosystems and human populations. New civilizations rise on foundations of old knowledge, even if incomplete. Mistakes are repeated. Lessons may be partially remembered. Catastrophic events create temporal gaps. Civilizations may vanish without leaving obvious traces. Geology, erosion, and time erase cities, artifacts, and infrastructure. Detection becomes increasingly difficult. The deeper the time, the less likely evidence survives. Some civilizations may have lasted millions of years. Their knowledge could have influenced humanity indirectly. Artifacts, geological anomalies, or technological seeds may persist. We could be unknowingly rediscovering their inventions. This theory explains anomalies in history and archaeology. Advanced construction or astronomical knowledge sometimes appears unexpectedly. It could reflect remnants of a lost tradition. Cultural memory may preserve fragments of what came before. Understanding cyclical civilization theory is urgent. It frames human history within a vast temporal context. It reminds us that intelligence is fragile. Technology alone doesn't guarantee survival. Wisdom, foresight, and adaptability are essential. Humanity may be the latest chapter. We have the unique advantage of observing cycles. We can learn from past rises and collapses. Avoiding previous mistakes could determine whether we survive. Cycles of civilization offer hope, but only if we understand the pattern. History is a teacher. The Earth's record hides warnings. Civilizations rise. Civilizations fall. Mistakes are repeated. Environmental collapse is a common theme. Deforestation, soil depletion, and overhunting destroy resources. Climate shifts devastate crops and ecosystems. Advanced societies crumble when they push beyond natural limits. Technology is a double-edged sword. It can solve problems or accelerate collapse. Industrialization transformed human life, but it also triggers climate change, pollution, and resource strain. Unchecked growth is dangerous. Energy consumption leaves marks. Fossil fuels, nuclear energy, and pollution create detectable traces. Past civilizations may have self-destructed through misuse of power. Understanding energy impact is critical for survival. Population management matters. Overpopulation increases vulnerability. Resources deplete faster than they can renew. Societies with unchecked growth face collapse faster. Knowledge preservation is vital. Libraries, texts, and oral traditions protect wisdom. Ancient knowledge may have been lost due to catastrophes. Modern humans can prevent this. Digital archives, cloud storage, and redundancy are survival tools. Disaster preparedness is essential. Earthquakes, tsunamis, floods, and asteroid strikes are real threats. Past civilizations may have been wiped out suddenly. We must anticipate, plan, and mitigate risks. Space exploration offers a backup for human survival. Adaptability ensures longevity. Civilizations that fail to adapt perish. Agricultural failures, societal rigidity, and environmental change are unforgiving. Flexible governance, technology, and social structures increase survival odds. Collaboration is non-negotiable. Isolation increases vulnerability. Past societies may have fallen because they couldn't respond collectively. Global coordination can solve planetary-scale problems. Wisdom matters more than speed. Rapid technological advancement without foresight is dangerous. Knowledge without ethical application can accelerate collapse. Past intelligence may have failed not due to ignorance, but hubris. The Great Filter isn't just natural disasters. It's repeated mismanagement of resources and technology. Learning from the past is our advantage. We can avoid pitfalls that eliminated previous civilizations. Time is limited. Geological processes and human expansion are erasing traces. We have a brief window to understand, adapt, and prepare. Survival depends on recognizing patterns and acting decisively. Humanity's challenge is clear. Avoid environmental destruction. Preserve knowledge. Plan for disasters. Adapt, collaborate, and use technology wisely. The lessons are in the rocks, ice, and fossils. The Earth whispers warnings through time. It's up to us to listen. The future of intelligence depends on whether we heed them. Survival isn't guaranteed. Earth has hazards. Asteroids strike. Volcanoes erupt. Climate shifts abruptly. Civilizations can vanish in centuries or less. Planetary defense is critical. Asteroid detection networks scan the skies. Impact trajectories must be calculated. Deflection technologies are being tested. Even small mistakes could be catastrophic. Learning from past cosmic events is essential. Sustainable technology is a survival tool. Energy systems must minimize environmental damage. Fossil fuel dependency accelerates climate risk. Clean energy reduces long-term planetary stress. Materials should last centuries, not decades. Efficiency, recycling, and smart design matter. Global cooperation multiplies resilience. No single nation can protect the planet alone. Sharing knowledge, technology, and resources is essential. Unified planning reduces risk and prepares humanity for emergencies. Space colonization offers redundancy. Mars, the Moon, and orbital habitats are backups. A self-sufficient colony beyond Earth ensures survival if a global catastrophe strikes. It also allows experimentation with sustainable technologies in controlled environments. Humanity becomes multiplanetary, spreading risk across the solar system. Redundant infrastructure is key. Food, water, energy, and medical supplies must be secure. Civilizations collapse when essential systems fail simultaneously. Distributed networks reduce vulnerability. Monitoring and early warning systems save lives. Climate sensors, seismic detectors, and orbital surveillance alert humanity to threats. Foresight allows action instead of reaction. History shows waiting too long is deadly. Education and foresight build long-term resilience. People must understand risk, resources, and consequences. Cultural memory preserves strategies that prevent repeated mistakes. Knowledge isn't just power, it's survival. Flexibility and adaptability are non-negotiable. Rigid societies fail under stress. Rapidly changing environments demand rapid response. Innovation must outpace destruction. Technology and ethics must work together. Advanced tools without wisdom are dangerous. Artificial intelligence, genetic engineering, and energy technologies carry massive risk. Ethical frameworks guide safe application. Finally, humanity must act now. The lessons of the past aren't hypothetical. Geological and historical records reveal cycles of rise and collapse. We have the chance to break the cycle. Planetary defense, sustainable technology, and space colonization aren't optional. They are essential survival strategies. The future depends on foresight, planning, and cooperation. The clock is ticking. Civilization's next step could be its smartest or its last. The stage is set. Earth's history is a warning. Civilizations have risen. They've flourished. They've vanished without a trace. We are here now. Humanity holds unprecedented power. Technology, communication, global coordination tools previous species never had. Yet power alone isn't enough. The Great Filter looms. Environmental collapse, nuclear risks, climate tipping points, asteroid impacts, they are real. Every warning in the geological record shows one truth: civilizations that fail to adapt perish. Time is short. Decisions made today ripple across centuries. Will we innovate wisely, or repeat the mistakes of lost civilizations? Survival is not just technological, it is moral, ethical, and strategic. Sustainable energy, planetary defense, and space colonization are steps, but only steps. The human mind must match the scale of the challenges we face. History is a library. Rocks, fossils, ice cores, they whisper secrets of the past. Technological civilizations may have existed before us. Their rise, their collapse, their mistakes, they are cautionary tales etched in stone and dust. We must read them, interpret them, learn, apply that knowledge before it's too late. The Earth is fragile. Our civilization is young, yet the potential is immense. We could break the cycle of rise and collapse. We could become a species that transcends its planet. But the alternative is real. Unchecked resource depletion, runaway climate change, or a cosmic impact could end us. We could vanish, leaving only subtle traces for future species, if any, to ponder. Our window of opportunity is fleeting. This is the ultimate test. Not just survival, but wisdom. Not just technology, but foresight. Not just innovation, but humility. We stand at the crossroads. The choice is ours. History has given us the lessons. The tools are in our hands. The challenge is clear. Avoid the errors of the past. Future generations may judge us. Will they inherit a thriving civilization, or a cautionary tale of hubris and neglect? The clock is ticking. Every action counts. Every decision matters. Humanity's destiny hangs in the balance. The test has begun. Will we rise to the occasion, or will we become another forgotten civilization, a whisper lost in time? The choice is ours, and the consequences are eternal. Subscribe now to join the journey of discovery, survival, and unlocking the secrets of Earth's hidden past.